today. I would especially like to welcome a new member, Phil Matheson, and his partner Debbie. Phil's from out in the dark mushrooms, and he's from Takanini in Auckland, so we won't hold that against him. A big welcome to our overseas visitors, Mick Daly from Australia, Stuart Whitehall, whose company is Future Game in the UK. Stuart has been a regular visitor to New Zealand, good supporter of the conference, so good to see you again. Thank you. And Mark Irwin, who we're very lucky to have as a guest speaker today. Mark, you're probably guessing, so knows from the UK. A big thank you to Stuart for sponsoring Mark and bringing him halfway around the world to share his mushroom growing experiences and knowledge with us. I'd like to thank BVB. I'd like to thank the sponsors now. I'd like to thank BVB from Holland. They're the European peat suppliers, and Global Access from Australia. They're mushroom supplies. Both companies are contributing to the morning tea this morning and towards last night's fuels cost. Unfortunately, neither company could attend the conference this year. Thanks to Corey and Jackie at the back from TNZ, who supply casing to the industry. TNZ is sponsoring our lumps, so thank you. Also a big thank you to Mick from Sylvan, Australia. He's been a big supporter of the New Zealand mushroom industry and sponsor of our conference for many years. Mick is very kindly sponsoring tonight's conference dinner and drinks at the loading ramp. That's at 6:30 onwards for pre-dinner drinks. So the loading ramp is you just go out the door towards Havelock, keep on the side of the road, just cross over the road, go the block and into first left in Treacher's Lane. It's about 2 minutes walk, so not far to stagger home afterwards. So I'd just like to have a round of applause for the sponsors, please. And before I introduce Mark, maybe we could all assemble out the front car park out here at say 1:25 p.m. just to make sure we've all got rides. So I've introduced Mark. Mark started as I've been Googling him.
Oh, God.
Mark started as a trade grower in the UK in the 1980s. He's done a lot of global consultancy, advising on tray and shelf grain farms, and composting projects and casing management. And Mark and wife Kate have owned and run their own Greba mushrooms, is that correct?
That is correct.
On the Isle of Man. I think that's a tax haven, isn't it?
No, I wish it was. You run a business like that, you get clobbered.
Mark is currently working on an organic farm project, producing its own raw materials and compost to service to existing growing units. So we have a very busy and interesting morning ahead, so thank you.
Okay. Oh. Right. Which was the first bit? Stuart? Nothing's happening.
Just go to the other thing. Yeah. Should move. No.
Something happened. Yeah, there we go.
Okay.
Perhaps I didn't press it hard enough. I mean, Martin's just said that, but as I say, one of the things that I've always tried to do is to give people real practical support. There's plenty of information out there, whether it's in a book or the internet, but often people's difficulties are quite specific to their materials or their sites. So it's really trying to look underneath what is going on. I do provide a certain amount of training either on my own farm or with other growers. And I've been working in the mushroom industry for about 30 years or something. I really don't know where the time has gone, in all honesty. I'm now based in France, working on this project, which I think will probably take about 3 years to get through the first phase of it. I think we can probably dispose with that bit. Right. What my client has done is she's bought an old dairy farm, and we're in the process of transforming that into a composting site, and we've done it from the middle so it can grow out in the future. And we've found, like all these things, we've actually had to for example, improve the infrastructure and the drainage more than we thought. But one of the interesting points with the site was that because it was a dairy farm, it's on one level, and even the rainwater all drains back to the point. So we should be able to manage the water very, very effectively. And in that part of France, there's quite a problem with the water aquifer. So water storage and water management is very, very important. And although at the moment we're not under any sort of legislation, we will be. And the authorities have been very helpful in this project in that they're going to actually see what we do in the first year before they start deciding what can and can't be done. The other really interesting aspect with this site has been the storage facilities, because if she had set out to build the buildings that were required and the concrete yardage, it probably isn't viable. It's a very tight budget as it is, and certainly the first sort of 3 years of its life will be tough. The concrete yardage really comes from where the old silage pits were, and fortunately for us, that's the only bit of concrete that's held up. Everywhere else we were told that the concrete was reinforced. Most of it isn't, and every time we've put some plant or machinery on it and tried to do some work, it's collapsed. It's very soft soil, it's very sandy in the area as well. Brittany. She's an organic grower, and the status of this site, it'll take about 3 years to turn it over to be fully organic. So at the moment we are buying in a lot of our raw materials, particularly straw and that sort of thing. We've found a very good source of chicken manure, which has only got 12% moisture, so it's a very friable product. It's used by other organic growers in that part of the world as a dressing, a basic fertiliser, and it certainly comes within the bands of the sort of nitrogen, water, dry matter that you would look for from a basic product. When this period is over, some of that straw will go to local stables to provide organic horse manure. We do have a source, if we wanted it, of organic pig manure, and we can grow different types of straws. And during our first year, we are not using just wheat straw. We have some triticale, which has actually been pre-sown with beans. And one of the reasons that that is of interest to us, because it's a green plant, the nitrogen in straw, everybody always talks about it being 0.7, 0.8, but certainly in my experience, it's nearer 0.4, 0.5. So we're hoping naturally to try and help keep that level up. The end output that we want from the bunkers will be about 530, 550 kilograms. I know that there is, and certainly has been some talk in other parts of the world of increasing this. We will have to wait and see what we can do. I was hoping that I would be able to give you some sort of facts and figures about some of this, but sadly, like all these projects, we're running about 3 months behind where we should be. So we still don't actually have any compost on the floor. This is just a photograph of the what was the cubicle yard. Where the red tractor is where the bunkers are now. This frontage and roof has all been removed, so it's all been opened out. The plinths that the cubicles were on have gone. This is currently dug out, waiting to be infilled with concrete. And it's along this slope here and down here that all the drainage either goes down the back of this barn to a sump, or around the outside of the edge of the next barn into the main drain. This is how we've laid out the floor. We've used small right angle sections with bent down iron to set the pipe work down and screw it to the floor. It has been done before, and this is a fairly common way of doing it. We've tied our pipes over with wire on each one as we've filled the floor in. But if you don't secure the pipe work, it can float once the concrete goes down. And as I say, I do know that has been done, and it's like all those things, the damage is irreparable, and the biggest problem is often that you start chipping off the concrete with a fork or a bucket. Okay. We've been very fortunate, and again, this is in part why we selected this site. The pipework goes through the built bunker wall, and we go through back into the old collecting parlour, which is where the manifold and the fans will be positioned. All the wiring can then go back to the old parlour, so we're able to utilise quite a lot of the cable work that's already on site without having to rebuild it and put conduits in and everything. This is the completed floor with the spigot set out, with the timbers on the top to form the grooves, which I'm sure most of you have done before, because I think there's bunkers here and all sorts. So it's all very standard. We have the drain port is here. It goes down that back wall with the rainwater, so we'll get a mix of water. We also, with the farm, we inherited a 75 cubic metre slurry lagoon, which also has a pump, which is very helpful. We're planning to turn the water over on a weekly basis, so we're not looking to store any dirty water, because we are limited in terms of storage, and we estimate that we would use somewhere between 2/3 and that tank a week, depending on whether there's any rainwater added to it. I haven't got a photograph of it, sadly, because the builders were in the middle of doing it, but we've also built a dipping tank, because we are going to dip the bales for probably a minute and a half in a very standard way, and then in the barn behind this wall we will be able to store the straw. This is the completed bunker floor, which went down the Friday before Stuart and I came out here, so it's certainly fresh off the press, and the wood and everything is yet to come out. And again, the water on the outside of the building will run at the front at this seam and go to the drain, so we shouldn't have any real problem with standing water. I'm sorry, we'll have to just pass through this because it's my fault. I put it in. I thought it would come up as a one to pass before the next aspect. Okay, for me, from a composting point of view, the most important feature and skill I've always termed physical property management. And I think we all can get the information, whether it's water, chicken manure, gypsum, but quite often the difficulties with composting is when it just becomes a solid mass. We're going to use some very simple equipment, because again we can only budget so far, and we're not having a line or a machine to do the breaking. We're actually, once we've wetted and warmed the bales, we will break them open for about 48 hours, and they'll then go through a converted muck spreader. We've created space as well, so if we need to do this more than once, which I suspect we will, we can do that. The analytic pointers. Everybody's got their favourites. For me, I find the carbon-nitrogen ratio very helpful. I'm always very interested in the fresh weight ammonium figure, because if it's up or down, it's certainly telling you what is or is not going on. And obviously the water levels. We're looking to make a compost with very good inbound water. Because we can't have a lot of water slopping about around the site, but also if we get the water in early enough into the straw, we should get good swelling and therefore good absorption. So management of the structure and the texture, to draw it all together, that's really what we're looking at, and we have enough time and enough space to do that. We're putting the emphasis on the product and not necessarily the process. We'll make the process suit the product, because at the end of the day, it's all about mushroom growth. So it's going to be what you eat, and there's lots of papers in the past that have been written very much about how to utilise the cell contents that are left behind for the mushroom. We want to try and avoid getting ourselves into difficulties with wet anaerobic materials that are then going to cause problems later, particularly in phase 2. Okay, the time and the space, coming back on that, because of the layout of the site and how we've set it up for the future, we're able to use a fairly basic machinery mix, and whereas for a lot of yards they would have a static line, they're quite fixed in their boundaries where they can be. We're going to do it in a bit more of a basic way to start with a tractor and a muck spreader, so we need to have room to operate. The moisture distribution and redistribution will very much be a part of that. When we start the plant up, we're not looking at any fancy pumps. We have a slurry tanker as well, which we've already tested, and 4 fills of the tanker or 4 empties of the straw tank will manage it on a daily basis. So when we know exactly where the water levels lie and what we use, then we could start looking at some form of recirculation. By doing it in that fashion, we won't need to have any aerator pumps or macerators at the beginning, and it's all these little things that often add significantly to budgets, because as you all know, none of these things are cheap. It will also help keep the electricity cost down in the first place. Once we've got the water we feel we need into the straw, we've then made the basic pre-wet mix, we should be in a fairly sensible position to redistribute water as and when we want to do so. The basic work will all be done under cover, because it is quite a wet area in the autumn winter where we are, and we should be able therefore to avoid these huge dumps of water, which actually can cause quite significant problems in composting terms, by sealing off the outer layer and cooling down what's underneath, which then slowly becomes more anaerobic. And I think sometimes it's those areas that can often, particularly with a bunker, they heat up later, but they were anaerobic material, and when they go and get redistributed into the phase 2, they're often the sort of types of materials that can cause problems with ammonia clearance, because they're not actually the same as the rest of the compost. In terms of adding water, apart from the tank, we're looking literally at using some simple irrigators and hose pipes to begin with. When we know where to position pipelines, we will do it afterwards. As I mentioned earlier, we've found a very good chicken manure source to begin with, and other than that we're really just looking at gypsum, which we'll apply like everybody else at 30 kilos a tonne, and it will be mixed in with the chicken manure fairly early on. We've also got a barn in which this can be stored dry, because it will be delivered dry. Again, very simple operation. It will come in a walking floor trailer, and we've worked out roughly we need about 1 delivery every 3 to 4 weeks. So a very simple operation that the driver can drive into the yard, back into the bay, offload and go. So we won't have any excess handling, and it won't be getting wet. We have space in the barn, as I was saying before, where we'll be able to back the spreader into position. We've also in the process of building a stronger back wall, so if any nuts and bolts fly out or bits of brick that are caught up, it's not going to do any damage to any people or any buildings. We can put it through once, and I suspect we will immediately reblend it, but again, until we start doing the work, we won't really know how many times we're going to handle the material. We should also, by what we do, minimise the runoff. So I hope by being in the right temperature ranges with the right texture, we should see the temperatures elevate in the correct way. In the early stages, we want to be in that sort of 50-60 range, so that we're still softening and working, so it's more biological. But by the time we get onto the bunkers, then obviously we can get up into the higher ranges for the chemical stages to start to take place, and also not have a lot of water running back down in the compost down onto the bunker floor, because the bunkers actually are designed for a bigger tonnage than we will start with. So we feel we've got, and the fans actually to match. So we're quite wary of having a lot of water that might be floating about at the bottom of the compost mass, and that with the air pressure that we've got, that we're literally just lifting it up and down in the bottom half of the bunker. There are some sort of physical cultural limits of the site, and really we've tried to push them to the outer edge, not to get too involved. Some of it is very old, and in fact one of the things we have had to do is abandon the old irrigation lines on the farm because of the leakages we found. So we did actually end up spending about another €15,000 that we weren't anticipating on putting drains in, digging out areas to put the pipes in. At the same time, in some ways, in fairness, we've also been able to put the new cable work system in because we've had to go for a much bigger energy supply than was previously there. As I say, we've built a dipping tank, and one of the things that we have is the area to put the straw after they've been dipped. And in fact, what we're going to do is we're going to put them up on pallets, and we're not going to stack them tight together, so that as the bales are warming up, they can draw more oxygen, which is actually very, very important. I think a lot of straw, sometimes when it's all clamped up together, certainly in the middle areas, there's not a lot of oxygen going in there, and often when you see that material broken out, there's probably a difference of maybe 20 or even 30 degrees centigrade sometimes. Oxygen impact, that's it. That's all we're really interested in. As long as it's breathing, so we've got the structure, the temperature is rising, the water is there, it will draw the oxygen, it can give off ammonia, and it can give off CO2. So we should be in the right place through all our preparation work. We've bought the equipment for the farm through Traymaster, who I'm sure many of you know, may have kit from or whatever. Robert is doing a grand job after his father. He's probably a bit calmer than Barry was. And he's worked on these tunnel projects, converting sea containers with a steel floor. What's quite interesting with these is that they have a much smaller air outlet. Standard grill floor is about 30-35%. I still haven't got the final figure out of Robert because he keeps changing it. But what is interesting is that we do think, and he's certainly got results coming out elsewhere, because there is less airspace, he seems to be getting more tons out. There's less removal or loss of material. Our machinery's got slightly bigger wheels on it, so that we've beefed it up because some of the concrete's not that even, just to make sure that everything will move as it should do. And I've certainly worked on projects in the past where the wheels wouldn't run on the concrete, so everything was stuck in position. And then obviously it's re-engineering and all the extra cost that goes with that. At the moment, we haven't really added too much to what the basic setup is. Again, we're going to wait till we start moving, but the filling hopper, we've got plans for that, to add extra spinners so we can get more intimate mixing of materials, and also where we are going to add water at certain points. If we need to be adding water up to going into phase 2, so be it. I hope we don't have to add too much water at that point. I don't personally like doing it. I'd rather have it in earlier. And certainly we'll be able to make that manipulation should we do so when we come to fill the phase 3. You can see here on the hopper, as I say, we will have plenty of space to work there and out the back. I did do some work some years back with a big hooving hopper similar to this, and we mounted a large spinning plate underneath where the compost came out and threw it back against a hood, and it made the most remarkable impact on the evenness of the material going up the elevators, that what was very, very lumpy and uneven suddenly became very uniform. Therefore it improved the filling process, so the man that was either filling the tunnels or the bunker, he could keep the filling equipment at a very constant speed coming out, so that we got less irregular areas within either the tunnels or the bunkers. We have to consider some of these aspects, because I think a lot of the big composters, where they're making hundreds and thousands of tonnes, they have these overhead filling gantries. We're going to have to be very careful how we mix and match materials. We have got time and we've got space to do that, so we're just looking at an alternative way. The principle is exactly the same, so it is a simple mix we can add to it. I think you can see from the pictures where there are points that we can check for moisture distribution and redistribution as and when we want to do so. Additives should not be a problem. They will all go in at the beginning of the cycle, so they'll be constantly mixed through. I think we've said enough about that and minimising the water. So everything up to this point is optimal for the bunker. Again, just a picture for you. This is the winch which we'll be using, and happily, because I know somebody else in the audience is waiting for the machinery. I've been able to see it, Clive. This is the filling cassette. And again, we've got a slightly beefed up front conveyor, because it's going to handle 3 types of compost: phase 0, phase 1, phase 2 and 3. And we've also got 2 speeds on it, so we can get different capacities of filling. I think that's where I put the wrong one in, I'm afraid. We'll have to... And then here you can just see where the air handling is built at the back of the container. They're all mounted on these legs. We're actually turning our air handling units are coming round by 90 degrees, because one of the things that I learnt last year when I moved to France, and the European climate is starting to change. And it actually was a lot warmer, and has been the last few summers, than they would normally expect. We've daytime temperatures up into the mid-30s, and they can often run through for 4 or 5 days at a time. That means that the temperature at night time doesn't really come down much below 22, 23 sometimes, and we're extremely concerned with the phase 3 that we'll be able to take enough cooler air to ventilate, to control the tunnels in the summer, drying them out at the same time. So we're going to have a cooling coil fitted that we can put in place in the warmer weather to cool the air going into the ventilator unit. We've calculated that we only need about 25 kilowatts of cooling, because within, if you like, a 4-week period, 4 tunnels, or the stages of the phase 2, phase 3, you only really need that risk is there for about 6 days, although it is split between 2 tunnels as the spike begins and the spike finishes. I don't see a great problem with the cool down of the spawn run at the end of the period, if we've been able to manage the spike properly. We've got about an hour's distance from the compost site to the farm, so obviously we're going to take it out and get it into our buildings fairly quickly. There's a lot of growers, certainly in Europe. I don't know about you guys, but you're often looking at quite a long journey. Now, one of the reasons that this whole project has come about is because my client at the moment is shipping compost from the UK and from Holland. And when there's a hold up with the transport for whatever reason, and we had 2 or 3 composts last year during the summer that sort of turned up at 40, 45 degrees, we managed to make something of it, but you're always, as I'm sure you all know only too well, very, very compromised. And all those composts were somewhere between 100 and 120 kilos different in terms of their output. And they create a lot of extra work and cost to actually look after what you've got. And I was talking with Clive yesterday. We are of the same belief. We never give up. We change the programme. We know we're going to be late, but we will make something of what we've got, because we have no alternative. We haven't got a big site, we've got orders to fill, so we've got to come up with them. If we know we've a problem, we can start working on it, we can start stocking mushrooms into 1 week for another, and so on. Okay, just sort of coming back with watering, by being intelligent, I hope, with how we want to apply and manage our water, we can help the decomposition. I certainly have seen in the past, I think it's a lesser problem nowadays, but where enormous quantities of water, which is actually very anaerobic, is just being swilled around sites. We've got that in mind, and we know the areas that we want to irrigate, and we know where we need to perhaps be a bit more internal in our application. That should give us the decomposition that we're looking for. So far of what we've seen, the quality of our straw is actually very good, which is great, and I think it's probably going to take a bit of work in the later autumn each year to get it to de-wax and decompose properly. We've got a longer process time to start with. We very much hope that we will be able to reduce that in the future, but I think that it's better to play the safety card than look at a very short program to start with. The moves and the cross-mixing are a bit of a concern to us because we know we don't have that intimate mixing that you get on these big yards, and I think often people overlook moving from one conveyor to another conveyor. Everything all the time is being opened up, it's being remixed, and it's at these little points you can add water carefully without over irrigating and drenching materials, and of course there's always that risk of washing out not only some of the material but removing the temperature. The weather, as I say, it can be very inclement at times, and we know that it can be very wet, so that's why we chose the site, that's why everything is undercover. The only bit, sadly, that at the moment is not going to be undercover, and that's really down to economic reality, is where we fill and empty the containers. We did look at putting just an open barn across the top, and we'll have to wait a few years to do that because we think other things are more of a necessity. It would appear in the area that we are that the materials are available, and my client at the moment is building up a very strong network of local organic growers of cereals. There's quite a change in France. In French agriculture, there's a lot of older farmers retiring, and those that are family farms where younger members of the family are coming into the business do seem to be looking to do things in a different way, and there's a very big interest, and they seem to have a very developed organic movement. All the mushrooms that are grown at the moment are going into, I suppose, what you could describe as an organic franchise. It was started in the, I believe, in the late 60s, early 70s, and these shops can be quite small to standard supermarket size, depending on their location, and they tend to buy their fresh products within a locality, and we have seen about a 10-12% increase year on year in sales of mushrooms. So again, my client believes at the moment that this huge outlay and risk is well worth taking. Certainly the buyers are very well aware of what is being done, and they have bought into the project. They're very keen for this to go forward. I think mainly, like a lot of countries in Europe at the moment, that they're not buying in materials from somewhere else. They're utilising much more of their own resources, and of course it's providing local employment. Just a little bit really about the phase one itself, because I know you had a fairly wide-ranging conference on all these aspects last year, so I don't really want to go over too much and teach you to suck eggs. But as long as we are seeing the right levels of fermentation from a physical point of view, that you can see the compost changing at each change and stage, and that we can record the correct temperature ranges according to the data that is available to all of us. We will be trying to reduce that schedule time, but we don't know till we do it. My big concern at the beginning is that I am able to get enough low temperature work, the biological stage is done, that the materials are softening, are absorbing water, because as I say, I don't want to be going about adding a lot of extra water, cooling compost down, washing out the chicken manure, and then again, if it is anaerobic and trying to work at the wrong stages, then you're needing an increase in air or ventilation, how you want to look at it, and you're blowing all the ammonia out. The chemical phases should all follow through like they all do for everybody, whether it is a stack composting system or a bunker, providing that that pre-wet work has been achieved as we intend. This is the intended program, if you like. One of the things that we've had to do, it's simply not possible to do weekend work. You cannot get the staff to do it. It's a weekend and a Friday evening in France are sacrosanct, as I'm sure many of you may know. So what we will be doing is we will start with the we will start with the dunking of the straw, which if we need to, we can do over 2 days. I don't think we will. The following Monday, we will start the pre-wet process. This is where we've probably got a fairly heavy day actually, because that material will have to go through the machinery. But if I find it is a problem, I can go back to the previous Friday, because I've got plenty of room to do this, and I'm not going to put anything else in jeopardy by taking up space where it's not, it's going to be used for another job. We think we've got some idea of the number of tasks and the staff available, or the requirement for those days. On the Monday, as I say, I think that material will go through the muck spreader at least twice, if not 3 times. It will then have the opportunity to sit for a day, and then we will reblend it with the horse manure and top anything up. In terms of the poultry, I've put a percentage of both. I'm probably looking to put somewhere around about 70–80% in on the Monday and just top it up, and with the horse manure on the Wednesday. So the bulk of it would be earlier rather than later, and that will keep it well away from the filling of the phase 2. The final blend will be done on the Friday, and we will fill that into the first bunker. So what we're hoping to try and achieve is a bit of an aerated pre-wet. It's a bit of a compromise between the two, but I would be concerned about that sitting as long if we don't get some air to it, but we don't have the equipment to shorten that period at the moment. It would mean that we could then have we would then have two periods of phase 1 proper in the bunker. So we would mix and move the material in the morning, and it would have a good 48 hours plus, hopefully getting up to sort of 75 plus within about 17–18 hours. We haven't got any fancy equipment in terms of monitoring. We're going to do that by hand to start with. I've got 2 people who've never been near a compost yard before, one of whom's very keen, another one used to drive tanks for the French army, so it could be quite an interesting combination, I think. We would then be able to get another move in and another 48-hour period. We're probably going to, at the moment we've got it down for the morning, but we may well move that emptying of the bunker to later. And I know that there's quite a debate with either moving bunkers and allowing for a bit of regrowth for actomycetes and so on and so forth, all the thermophilic flora that you need. But I was talking a while ago with Simon Middlebrook in England, who runs Tulltech North, and he's actually taken his compost directly from his bunkers to his phase 2 now. But in part, I think that there's a very long length on their conveyors to get from one part of the site to another. So that at the moment is a bit open to debate. That would mean that we could fill the phase 2. Obviously, we would be doing that in the afternoon once we start, because we'll have a spawning every week to do thereafter. Obviously, the first week, there's nothing there. We then have a 16-day phase 3 period before the farm will receive the compost. A benefit we will get on the farm is, because at the moment we're importing blocks, is basically we get a day's work back, and that's the heaviest and most costly day of the work. It's the biggest labour day on the farm to do that. So that's a return straight away to the business. On the Friday, as you can see, there's not a great deal to do, but obviously between Thursday afternoon and Friday, the yard work, the machinery, hygiene, maintenance, all those jobs will be carried out. We've yet to sit down and draw it up, but we will work to a weekly schedule. And I think, like all these things in this day and age, at the end of the day, there'll be a sheet of paper and somebody will tick the box that it has been done. And then this here is, I'm standing in the bunker. These are the silage, or were the silage pits, which are, the walls are being dismantled at the moment, and we've got the 2 plinths up here ready to receive the containers, and then all the cable work and everything will go down. There's a small office about here, so the control centre for everything will be on this side of the plant. And in the future we can take the composting phase 2, 3 that way should we wish, and the composting pre-wet, phase wet handling could come back towards me. So we're in the centre of the site at the moment. And that is the first part of my talk. I don't know if anybody's got any questions, or I don't know how much time we've got left actually. I know Martin's looking at his watch.
Yeah, we've got plenty of time. Stuart was 9:30, but I'm sure he can come sooner. Any questions?
With those big containers that you've got, what kind of a gap do you have underneath the air?
Are you talking about the air under the compost? Yeah, in what would be a traditional? Yeah, yeah. What are you talking about? The plenum actually underneath the compost in the container? Yeah, it's a tube work system, very much like a bunker floor, and it's got a slightly bigger hole, because a lot of those containers have a grid floor, and what's been manufactured is a steel sheet which has got holes punched out in it. So you are able to pass air through at different volumes, different speeds, just as you would do with a normal plenum. What we have to look at, and we are a bit concerned about, is we would like to add some cold water with the spawn running, particularly in the summer when it's hot and dry. But because we've got very limited space, we're a bit concerned about blocking up the airspace with water. So that is something we have to work on, albeit one of the things we've already done is we've slightly increased the space of the air handling unit. So you could add a box underneath, so your air would be passing over a pool of water, for example.
So you spawn or fill onto a net and then pull it out?
You know, if we went back to the first picture of the machinery overall, the filling machine will be in the tunnel, filling onto the net like any other tunnel. So when you've finished, and then the winch will butt up to the container, and then it will winch out the compost, pass it up the conveyor. We can go into a lorry, or we can go onto that conveyor system to go round the site, and you can go left or right to fill any way you want to, because obviously the other thing that we do want to do is we'll move a container every week, so every container will have had a pasteurisation process once a month. Okay.
In your diagram, you had Duncan 2 separate days.
Yeah, yeah.
So do you So is that you're splitting your compost?
No, not at all, Martin. It's time and space actually, and I'm playing the safety card. Ideally, I want and should be able to do it in a day. It's just finding the right time to fit it in. What I would really like to do, if I can do that work on a Wednesday, I probably would pass that material through the spreader on the Friday, so that I have at least broken the bales up, as long as I don't lose too much temperature, because I do think that temperature you get in a dunk bale is very important in terms of the softening or the speed of it, but it does give you a very consistent start point. Much more so, I think, than more traditional methods of dipping and dunking and so on.
It's quite a short period from dunking to actually break.
When you're dunking bales, actually, once that water is in there, it doesn't need a great deal of time. And certainly, I think some of the bigger yards that I've worked on in the past, it's often standing there because it can't be moved. If they could get at it earlier, they would do. And it can be quite detrimental at times. So I think it's like all these things, especially where you have a big mass of material, because once you run out of oxygen, it starts reverting back to anaerobic processes. But everything that is there can either be shortened or lengthened, and that's very much how we will go about doing it. Stuart. Where were we? Right, restart. Okay, in terms of general assessment, obviously, like all of you, what we would be looking for is that phase 1 situation at the end of the bunker process. The density and the structure of the material that we have created, and I think, like everybody else, we are quite wary of creating something that is a bit green and then gives us problems in the phase 2. So we'd like to find a way to make something that's active enough to avoid that situation, and that we have the right density of material. I think the darkening is always a very interesting point, because sometimes if you take a handful of compost when it's ready for filling and you wash it under the tap, it can give you a bit of a shock. A lot of that dark material can wash off quite easily where you haven't really got caramelized. So it's just about being very, very careful. And the other thing that we are aware of is that we mustn't exceed the tunnel's technical capability. We think we can get somewhere around about 32 tonnes maximum of phase 1 inside the tunnel. And I know, and I've certainly read in the past, one of the Dutch advisors was suggesting that some of these problems, you only need small percentages over where your limits lie to give you quite serious problems in not being able to condition your compost properly. Obviously, we want to go in at the correct temperature for levelling. One of the other things that we have added to the site is a steam boiler. Now, in theory, we shouldn't need it. But when the weather is cold and wet and very windy there, it will give us the ability to have both ventilation and steam during that levelling phase. And we know that in that period, we'll be doing that work outside. So the compost could get wet and cold. I do not want to be in a position where you're just shutting the damper and waiting for the compost to react a day later, because like everybody else, we've got a schedule, we've got 6.5 days to do that work in. We cannot afford to lose 24 hours at that first point. It also is quite an attractive proposition that were we to suffer some weed mold problems or something in the future, which I'm sure we will, we have the ability to disinfect and sterilise the tunnel when it's emptied, because there is a small space of time after the phase 3 has left the site. The ammonia levels, again, very standard. The only quandary I have in my own head at the moment, and there's some quite conflicting evidence out there, but with a bunker process and the higher temperatures, it's always said to me that part of the cleansing is going on long before you get to phase 2. When you have a standard RIC system, that's obviously not true because of the outer area and the bottom centre core. I think that we would probably be looking to have a level of somewhere around about 400, 450 maximum, which gives us the time to be able to clear it down for spawning. As I say, we've only got a certain amount of time to deal with that ammonia if it is a problem, and I do not want to be damaging beneficial microorganisms, microbial proteins in the early part of the phase 2 process. So I think it would be pretty foolhardy to make a very high nitrogen compost with an excess and late additions of chicken manure. This is about 20 years old, I think. It was a sheet that I used for another job a long time ago, and I've just really put it up. I'm sure most of you have got your own thoughts and ideas on these things, but it was really making sure that you could achieve your aim, and that each time you filled your tunnel, you were going to try and do the same process rather than do it on the hoof. I think the one thing I would say straight away is that I would always extend the levelling period if I had to. And if I had to extend it, it would probably be from the point of view that the compost was too active or the ammonia was too high. That would mean that I could get some time back on my pasteurising. I've always been very wary of temperatures much above 58 degrees, and if, for example, I was starting to see 59, 60, let alone temperatures above that, I'd be very concerned about our actual compost making, but I would dramatically reduce the time of the pasteurising. I wouldn't allow the compost to sit at a high temperature with a lower air temperature. I think also a lot more work nowadays is done in the bunkers because most of this was all brought about when we were all RIC composting. Something else that we used to see was quite often if you were a bit too aggressive in your cool down after you'd finished pasteurising, you quite often, a day and a half later, used to get too much activity come back. So to come down more gently, I think, is very important. And again, you've got that sort of 48, some people say even almost up to sort of 50, 51 range in the conditioning. If you do get up to 52, 53, and you're needing these lower air temperatures again, then I think you're looking back to what's going on really with your compost. Because if the phase 1 was correct and the time of your operations is correct, you shouldn't really see those situations. This is the sort of thing that often happens when you do overfill a tunnel, because it's not designed, if you like, to look after that. And then as you get towards the end, you know, I mean, everybody, depending on the time of travel for the compost and how they run their spawn rooms, you've all got your own sort of area that you want to cool to. I do know some people who don't cool much below about 30 because it's got quite a long period of time to come out into the system, and by the time it's into the next tunnel ready for the spawn run, it's actually too cold. And I think the problem with that can be if you're looking to run your phase 3 sort of 22, 23 degrees after sort of the first day and a half, if you are too cold, you can actually lose 2 or 3 days just getting up to temperature. And then if that time took you to get up to temperature where you should have been peaking out around about 9, 10 to start that process, it will not happen until you get towards the end of the phase 3, and then you're going to go and seal that temperature in there with the casing. So you're going to incubate the problem. We always work from the casing backwards. If we are getting difficulties in the casing temperatures, we look very closely at what's going on with the spawn run. You know, some people are limited by the processes that they run. If you were making, for example, compost as a phase 2 end product, you can afford, if you have to take more time. But a lot of these plants now that are selling phase 3 to other growers, they're very limited in the time they've got available. So they have to be very wary of temperature and the amount of nitrogen, so that there is time there to remove and assimilate ammonia before spawning. Which brings me back really to the point about we want to make sure that all our poultry additions are done well away from actual filling. We should have about 14, 15 days. So really reiterating that point, if it's phase 2, you can afford to be slightly higher nitrogen, higher ammonia if that's what you want to do, because there's more time available. I think with phase 3, I think you have to be more much more wary of that aspect. And certainly when some of the phase 3 started being manufactured in the UK sort of 20 years or so ago, these were quite big problems. Composts were greener, and there were a number of issues with trichoderma as well, and it was really a matter of looking at this whole overall approach to how you run your bunkers, how long the phase 2 is, and also I think that's where this thinking came in, that there's much more going on in terms of cleansing during the bunker process, and you didn't necessarily need to be spending quite as much time and risking high temperatures during phase 2. So that is the end of that talk now. I don't know if there's any further.